All right, so this is 5.4 day 2. So we're going to be using the sum and difference formulas once again. So let's start up with this opener here. Let's find the cosine of 255. So you should notice that 255 is not an angle that we have memorized from the unit circle, but there are two angles that we have memorized that add to 255. There's actually multiple that either add or subtract to give you 255. Once again, if you're having trouble thinking of two angles, start with 30. Then if it doesn't work, move on to 45. If it doesn't work, move on to 60 and use it like that if you're having issues. So if I said 30 plus what equals 225, that is minus 30, 225. And those are both from the unit circle, okay? Or you can use 45 plus 210. Those are both from unit circle. Now, I don't want to do 60 plus 195 because 195 is not on the unit circle. See what I'm saying here? Okay, so I'm just going to use the 30 plus 25 because that's the first one I came up with. All right, also before we start, let's remember our cosine, sine, and tangent formulas, okay? Actually, our tangent's not on here, but I'm still going to remember it anyways. So cosine goes cosine, cosine, sine, sine, and this sign right here, you change the sign. Sine, sum and difference formula goes sine, cosine, cosine, sine, and you keep the sign. And the sign is right here. Okay, so if it's a plus, keep it a plus. If it's a minus, keep it a minus. And then for cosine, you change it. And then tangent, you distribute for the numerator, and then the denominator is 1, the opposite of that, so minus multiplying the two tangents. Okay, so I know that that's kind of funky looking right now. You can actually look at the formulas if you need them, but that's how I remember them. Okay, so let's start with this first one here. I said I was going to use 30 and 225, so I'm going to change this to cosine of 30 degrees plus 225 degrees. So I'm using the cosine sum formula. Cosine goes cosine, cosine, sine, sine, change the sign. So I'm going to do cosine, cosine, cosine of 30 plus cosine of 225. Cosine, you change the sign. This is addition, so I'm going to change it to subtraction. Oops. And then sine, sine, sine alpha, which is 30, sine beta, which is 225. So it looks like I'm going to be using 30 and 225 degrees. So I'm going to write down the ordered pairs for both so I can just replace them. 30 and 225. All right, 30 degrees is root 3 over 2 1/2. And then 225 degrees is a 45 degree reference angle. So root 2 over 2, root 2 over 2. Now I just have to think about what quadrant it's in to get the right signs. 225 is in the third quadrant, so it's left and down. So those are both negative. All right, now I'm going to do some replacement. So I have, I don't know how I got a plus sign right there. It's cosine, cosine, sine, sine. I don't know where that plus sign came from in my head. All right, let's move that right there. There we go. Okay, so I need these to replace these two, and then I have minus and replace those two. All right, cosine of 30 is root 3 over 2. Cosine of 225 is negative root 2 over 2. Sine of 30 is 1/2. Sine of 225 is negative root 2 over 2. Okay, so I'm going to multiply. I'm going to put the negative in front or in the numerator. It doesn't matter. I like to put it in the numerator because I'm not going to put the negative in the denominator. So that's negative root 6 over 4. And then I have minus a negative root 2 over 4. So I'm just going to change it to plus because it's minus a negative root 2 over 4. Now I can combine those. Common denominator is 4. And then I have negative root 6 plus root 2. Okay, and you can write it as root 2 minus root 6 if you want to. All right, next term up here, I have cosine 40, cosine 5 minus sine 40, sine 5. So first off, you have to notice that they're not complementary, so you're not changing anything to cofunctions. But instead, you should notice the pattern cosine, cosine, sine, sine. So you can simplify this to the cosine using the cosine difference formula. So I have the cosine sum formula. Now I know it's sum because you take the opposite of that for cosine. So cosine of 45 plus 5, which is the cosine of 40 plus 5. I was already adding them in my head, which is the cosine of 45 degrees, which is root 2 over 2. And there's the answer to that. Okay, so let's move on to the new stuff, which you're still using your sum and difference formulas. But if you notice, the problems are given to you in a completely different format, right? Okay, so it says, given the following conditions, the sine of alpha is 4/5, where alpha is in between 0 and pi over 2. And the cosine of beta is 1 over root 5, where beta is in between negative pi over 2 and 0. Then they want us to find the sine of alpha plus beta and the cosine of alpha minus beta, okay? So first thing, what we can do is realize what we need, but I always end up doing that part first, but I'm going to pretend like I have no idea what I'm doing. So I'm going to say, okay, I need to find the sine of alpha, so I'm going to write down my formula. Sine, remember, goes sine of alpha cosine of beta, keep the sine, cosine of alpha, sine of beta. Sine, cosine, cosine, sine, like a sine bread with cosine meat, okay? Alpha, beta, keep the sine. All right, so now if you notice, I need the sine of alpha, which is 4/5. I need the cosine of beta, which is 1 over root 5. But then I need the cosine of alpha and sine of beta, which I wasn't given, and I have to figure them out. So if I have the sine of alpha and I need the cosine, I need to know what that triangle looks like because I have opposite and hypotenuse, but I don't have adjacent, which is what I need. So what you're going to do is you're going to start off by, I'm going to erase these things I highlighted here. You're going to start off by drawing the triangle with the angle alpha in it. So I'm going to start off by drawing this. This is alpha, right? So that's an angle. That's one angle. All right, so if you look here, cosine is 4/5, which is positive. So I have to first ask myself, which two and I'm going to draw my triangles off to the side here. Which two quadrants is sine positive in? The first and the second. Right? So you've got it narrowed down to those two. But then it gives you a second clue, and it tells you that alpha is in between 0 and pi over 2. So here's 0, here's pi over 2. So your triangle, your angle, is in your first quadrant. I don't like how that wasn't straight. Okay. Your angle's in your first quadrant. That is alpha. Okay. All right, so what you're going to do now is notice that they gave you sine. Sine is opposite over hypotenuse. So we have to make this into a right triangle by drawing a vertical line that is perpendicular to our x-axis, make that a right angle. Now we can label the opposite side 4, and the hypotenuse is 5. You can use Pythagorean theorem to get the third side, but this is a 3, 4, 5 right triangle, so I'm going to jump to saying that's 3. All right, so now we can get sine and cosine. So now we can get both of these. We already have that, and we can get this using that triangle, okay? But we also need to do that for beta, so I'm just going to draw beta right now also, okay? So here is your stipulations for beta. So if you look, beta is positive. Okay, sorry, the cosine of beta is positive, my bad. The cosine of beta is positive, and then it gives us a second stipulation. So I'm going to draw it right below this one. So where is cosine positive? All students take calculus. So my angle is either in my first or my fourth quadrant. So now if you look right here, it says beta is in between negative pi over 2 and 0. So here's negative pi over 2. Here's 0. So that means it's in my fourth quadrant. So what I'm going to do is I'm going to make my angle in my fourth quadrant. Then I'm going to go ahead and connect it to the positive x-axis, make my right angle. Beta is created by your x-axis, your positive x-axis, and your terminal sides. That's beta. All right, so I was given cosine, so that's adjacent over hypotenuse. The adjacent side is 1. The hypotenuse is root 5. And I do need to use Pythagorean theorem to get my third side because I don't, that's not a triple. Okay, so I'm going to do leg squared plus leg squared, which I don't know, equals hypotenuse squared. You can call it x, y, b. It doesn't matter for the x right there that I put. Equals root 5 squared. 1 plus x squared equals 5. I almost said root 5. Subtract 1, you have x squared equals 4. And then square root plus or minus, square root plus or minus. So x is either positive or negative 2. We have to figure out which one. Since this is down, we're looking at this point right here, right? This is right and down. It's a negative 2. Okay, we've done this before. This shouldn't be anything new to you. Okay, so now we're going to use that triangle to get cosine and sine here. All right, so now I'm ready to go. I'm filling in 1, 2, plus 1, 2. Okay, I need the sine of alpha. Come up to alpha. That's opposite over hypotenuse. That's 4/5, which we already knew from right here, 4/5. Okay? I need the cosine of beta. So go to beta. I need the adjacent over the hypotenuse. That's 1 over root 5, which we already know because it was right here. All right, what we didn't know is the cosine of alpha. So here's alpha. Adjacent over hypotenuse is 3/5. And we didn't know the sine of beta. Opposite over hypotenuse is negative 2 over root 5. All right, so now we just have to simplify this. Multiply your numerators, multiply your denominators, multiply your numerators, multiply your denominators. So we have 4 over 5 root 5 plus negative 6 over 5 root 5. We already have a common denominator, so that's negative 2 over 5 root 5. But we also have a radical in our denominator, and we can't leave radicals in our denominator. So we are going to rationalize this by multiplying both the numerator and the denominator by root 5. You don't need to do 5 root 5 because there's nothing wrong with a 5. So now I have negative 2 root 5 over root 5 times root 5 is 5. 5 times 5 is 25. There you go. Okay, so now using the exact same information, we're going to do cosine of alpha. All the work is there for us. So all we have to do is fill in the blanks and know our formula. So cosine difference formula. Cosine goes cosine, cosine. So cosine alpha, cosine beta. Change the signs. This is going to be a plus. Sine, sine. Sine alpha, sine beta. All right, so you could look at your triangles again, or you can just look at this problem, right? The cosine of alpha is right here. It's 3/5. Put my parentheses all in. Cosine of beta is right here. It's 1 over root 5. Sine of alpha is right here. It's 4/5. Times sine of beta is right here, which is negative 2 over root 5. And then once again, multiply, multiply, plus multiply, multiply. So we have 3 over 5 root 5 plus negative 8 over 5 root 5. So that is negative 5 over 5 root 5. I can simplify this fraction before I rationalize because 5 divided by 5 is 1. So that's now a negative 1, and now I can rationalize. Multiply by root 5 over root 5, and I have negative root 5 over 5. Okay, if you didn't simplify right away, you would have 5 root 5 over 25, but then 5 over 25 simplifies. So that's why. Okay. All right, so basically, that is one type of problem. Here's another type, which we'll do 2 of those in a row. Okay, so you should be able to catch on, I think, from what we've been doing now. Okay, so example 2, find the exact value of, and now this right here, this is something I look at and I'm like, wow, if you showed this to an adult who's not in high school, who's not a math major and you're like, look what I'm doing, they're going to be like, what the heck is that? So what I want you to realize is this right here, tangent inverse of 5/12, okay? If I ask you, you're using inverse here, what is it? What is it? When you use inverse, what are you finding? The answer is an angle, okay? Same thing here. Sine inverse, that's another angle. So it's two different angles. So I want to label them with two different angle names, like alpha and beta. So what you have to realize is that this is the cosine of alpha plus beta. So now use your cosine sum formula. Remember, cosine goes cosine, cosine. Change the sign, sine, sine. So this is what we need. We need the cosine of alpha, the cosine of beta, the sine of alpha, the sine of beta. So once again, we have to draw our two different triangles. So we'll start off by drawing alpha, that angle, and then making it into a triangle. All right, so these are inverses. What you have to remember about inverses is that inverses are only defined in two quadrants. So you're not starting by drawing all four quadrants. So you ask yourself, where's tangent inverse defined? Tangent inverse is defined in quadrants 1 and 4 only. So it's either in the first or the fourth. It could never be in the second or third. This is a positive number, so it's in the first quadrant. So alpha is in the first quadrant, and I can label that angle alpha. Tangent is opposite, so this is opposite over adjacent. So opposite's 5, adjacent's 12. You can do Pythagorean theorem to figure out the third side by doing 12 squared plus 5 squared equals hypotenuse squared. And getting 169 equals hypotenuse squared, square rooting and get 13. Or you can have it memorized that it's a 5, 12, 13 triangle. Radii are always positive. The hypotenuse is always positive, so you never have to worry about the plus or minus. Okay, now let's draw beta. So this is sine inverse. Sine inverse is only defined in two quadrants, and that, again, is quadrants 1 and 4. So now I look, and this is a negative value. So I am in the fourth quadrant. So I'm going to go ahead and make my right triangle by connecting to the positive x-axis, and this angle right here is beta. All right, sine is opposite over hypotenuse. So I have opposite is 3, hypotenuse is 5. One of them has to be negative, right, because it's negative 3/5. This is down 3, so the 3 is negative. Plus, the hypotenuse is never negative, like I said. I'm just going to erase it. So we know it's the negative has to go with the 3. Now I need my third side, the other leg. This is a 3, 4, 5 triangle. The 4 is positive because it's to the right. Okay. So now I can fill in the things that I need. All right, so I need cosine of alpha, cosine of beta, sine of alpha, and sine of beta. So I'm going to start with the cosine of alpha. So here's alpha, the first triangle. This is oops, that's not adjacent. This is opposite, this is adjacent, this is hypotenuse. So the cosine is adjacent over hypotenuse, so that's 12 over 13. Now I need the cosine of beta, so come over here. This is adjacent, this is opposite, this is hypotenuse. So cosine of beta adjacent over hypotenuse is 4/5. Sine of alpha, go back up to alpha, opposite over hypotenuse, 5/12. Times sine of beta, go back down to the second triangle, that's negative 3/5. That is the one you were given the sign right here, so we need that beforehand. Okay. Now I just need to multiply, 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 and simplify. All right, so I have 48 over 13 times 5 is 65, minus 5 times negative 3 is negative 15 over 65. It's minus a negative, so you can change this to plus if you want. Okay, not if you want, you can, or you can think of minus a negative, which I don't think anyone does. 48 plus 15 is 63. So you have 63 over 65. If the fraction's simplifiable, you can simplify it, but nothing goes into 65 and 63. Okay? All right, let's try another one that's similar here. Find the exact value of the expression. So once again, this is an inverse, so this is an angle, so I'm going to call it alpha. This is an, oopsies. This is an inverse, okay? So this is also an angle, but it's a different angle, so I'll call it beta. So what we have here is sine of alpha. It's minus, right? So minus beta. And now I'm going to write out my formula for the difference formula for sine. So sine goes sine, cosine, alpha, beta, remember. Keep the sine. Cosine, sine, alpha, beta again. Cosine, sine. You could always check to make sure it's right after you write it, because sometimes it's hard to write it and think about it at the same time. So sine, cosine, cosine, sine, alpha, beta, and I kept the sine. All right, I'm good. So I need 1, 2, minus 1, 2. So I need these 4 things. So I need to draw my 2 triangles, the one that has alpha as an angle and the one that has beta. So I'll start with this one right here. It's an inverse. Inverses are only defined in 2 quadrants. So this one's cosine inverse. Cosine inverse is only defined in quadrants 1 and 2. This is a negative cosine, so that means it's in the 2nd quadrant. This angle right here is alpha, positive x-axis in your terminal side. Or sorry, your x-axis in your terminal side. Okay. This is adjacent. This is hypotenuse. Remember, your hypotenuse is always positive, so that's a positive 2. And your adjacent would be negative 1. This is not a triple, so I'm going to do Pythagorean theorem to figure out my 3rd side. Leg squared plus leg squared equals hypotenuse squared. 1 plus x squared is equal to 4. Subtract 1 from both sides. X squared is equal to 3. Square root plus or minus. Square root plus or minus. So x is either going to be positive or negative 3. Since it's up, it's positive 3. Okay, now I need to draw my other angle, beta. Tangent inverse, once again, is defined in quadrants 1 and 4. It is positive in the 1st quadrant. This angle right here, the x created by the x-axis and the terminal side, is beta. All right, so I have opposite over adjacent. Please realize that this is not written as a fraction, so you can write it as a fraction. Opposite, adjacent. Opposite is 1, adjacent is 1. Pythagorean theorem, 1 squared plus 1 squared equals x squared. That's 2 equals x squared. Square root plus or minus, square root plus or minus. So I have my hypotenuse. Remember, hypotenuses are always positive, root 2. All right, now I'm ready to fill in the blanks. So cosine of alpha. I'm going to go ahead and go in again and say this is opposite, this is adjacent, this is the hypotenuse. All right, so cosine of alpha, opposite over hypotenuse, root 3 over 2. I need cosine of beta. Okay, so I need cosine of beta. This is adjacent, this is opposite, this is hypotenuse. Cosine of beta is 1 over root 2. All right, now I need cosine of alpha. If I look over there, that's negative 1 over 2. And then sine of beta is opposite over hypotenuse, 1 over root 2. Okay, so now I need to simplify this. So I'm going to, or not, I guess, multiply, and then subtract. So I have root 3 over 2 root 2 minus negative 1 over 2 root 2. It's minus a negative, so I'm going to change it to plus. All right, so now I have root 3 plus 1 over 2 root 2. All right, I have to rationalize because I have a radical in my denominator. So I need to multiply both the numerator and the denominator and the numerator by root 2. Please realize this is a binomial, so you do have to distribute. All right, so root 3 times root 2 is root 6. Plus 1 times root 2 is root 2. All over root 2 times root 2 is 2. 2 times 2 is 4. And there is my answer. Now I realize that answer should look pretty familiar. It looks like almost all of our answers from day 1 notes. And that's because we know the angle that has a tangent of 1 and a cosine of negative 1/2. Okay? All right. So last but not least, we have verifying each co-function identity and then also establishing these identities, okay? So let's start with verifying these co-function identities. So please realize you already know this is true. You know that cosine's co-function is sine. We know it's true, but we're going to prove that it's true, okay? So we're going to circle the more complicated side, which is this. Now realize this is an angle. Let me highlight it. This is an angle, and this is an angle. So what we're going to do is we're going to call this alpha. We're going to call this beta. So really, it's cosine of alpha minus beta. So we're going to use our cosine formula, our cosine difference formula, which goes cosine, cosine. So cosine of alpha, cosine of beta, change the sign, and then sine, sine. Sine of alpha, sine of beta. Okay, so now what we're going to do is we're just going to clean this up. We know the cosine of pi over 2, and we know the sine of pi over 2. So let's think about what that is. Okay, off to the side over here, I'm going to draw a quick unit circle. So pi over 2 is the same thing as 90 degrees. That's the ordered pair over 0 up 1. So now let's replace. The cosine of pi over 2 is the x value, so that's 0. And then I have times cosine of theta. Plus the sine of pi over 2. The sine of pi over 2 is the y value, which is 1 times sine of theta. And now I can clean this up. 0 times anything is 0. Plus 1 times anything is itself. So I get sine of theta equals sine of theta. That's what I was trying to get, right? It's right there. See? Okay, let's try another one. So prove that it's true, right? So we already know that it's true because it's your co-function. But let's just prove that it's true. This is an angle, we'll call it alpha. This is an angle, we'll call it beta. This is the side that we are going to manipulate. So sine goes sine, cosine, cosine, sine. So sine of 90, cosine of theta. Keep the sine, cosine, sine. Cosine 90, sine theta. All right, same idea, clean this up. We need this ordered pair because it's 90 degrees again, 0, 1. Sine of 90 is 1 times cosine of theta minus cosine of 90 is 0 times sine of theta. So we have cosine of theta minus 0, which is cosine of theta. So we just proved that it's true. What we knew all along is true, and now we can prove it because we know our sum and difference formulas. Okay, so now what we're going to do here is we are going to establish these identities. It's very similar. So let's get started here. All right, so we need to circle the more complicated side. Remember, fractions are more complicated. All right, so now you have to say, what can we do with that? Well, we can expand this numerator using our cosine sum formula. So let's do that first. Remember, it goes cosine, cosine, sine, sine. So cosine alpha, cosine beta. Change the sign, sine, sine. Sine alpha, sine beta. All over. Cosine alpha, cosine beta. All right, so now let's say, well, I'm stuck. Okay? So if you do say that, remember, look at your answer. You're trying to get 1 minus tangent alpha, tangent beta. So ask yourself, what's tangent the same thing as? Sine over cosine. So I'm trying to get 1 minus sine over cosine, both alpha, sine over cosine, both beta. And if you look here, you should say, like, wait a minute. I see, I'm going to highlight and then erase, sine over cosine right there. Okay? So what you have to realize you have to do is you're going to have to divide. So you're going to have to divide. This, remember, is one term because it's just all multiplication. There's no addition or subtraction separating it. So I can divide this term in the numerator by that, and I can divide this term by the denominator. So I can break it up. So I have cosine of alpha cosine of beta over cosine of alpha cosine of beta minus sine of alpha sine of beta over cosine of alpha cosine of beta. So now I can clean this up, all right? Factor of cosine of alpha, factor of cosine of alpha, factor of cosine of beta, factor of cosine of beta. That's 1 minus sine over cosine of alpha is tangent of alpha. Sine of beta over cosine of beta is tangent of beta. And you're there. Pretty great, huh? Okay, why don't you go ahead and pause the video and try this one. Now this is not verify it's true and it's established the identity because this is pi and it's not 90 or pi over 2. So this we don't have memorized. Okay, this is alpha, this is beta. Cosine goes cosine, cosine, sine, sine, change the sign. So cosine of pi, sine, cosine, 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 cosine of theta, change the sign, sine, sine, sine of pi, sine of theta. All right, so now we need the ordered pair for pi. So I'm going to do a little sketch up here. Ordered pair for pi. Pi is right here. -1, 0. This is cosine, this is sine. All right, cosine of pi is -1 times cosine of theta plus sine of pi is 0 times sine of theta. That's negative cosine of theta plus 0, which is negative cosine of theta.